All right, so we are going to look at more electron configurations and how to write them. But we're going to look at it for multiple just random elements here. And so the first one I'm going to look at is phosphorus. So the one thing I want to do is I want to find phosphorus on here, and it's number 15. Remember, atomic number is number of protons, but also number of electrons. And so I know phosphorus has 15 electrons. And so I, again, just want to figure out where those are going. And so I first am going to fill my 1s sublevel. And so it fills with 2 electrons, and so it's 1s2. The next thing I fill is my 2s. And 2s fills with 2 electrons. So I've used 4 electrons so far. So I need to keep going because I have to go until I get 15. So I'm going to fill the 2p. Right, remember that we have 3 p orbitals, and so it can hold 6 electrons maximum. And so I'm going to go ahead and I'm going to put all 6 in there because I've only used 2, 4, 10 electrons. And so I have to get a home for 5 more. And so my next one I filled 2p is 3s. 3s fills with 2 electrons, and so I put those 2 in there. Again, now I'm at 2, 4, 10, 12, and so I need to find a home for 3 more electrons. And so my next diagonal tells me I fill 3p. And so I'm going to come in and fill 3p. Well, I've already done 2 electrons, so I only have 3 in that p orbital, because that's all the electrons I have for phosphorus. And so this is the electron configuration for phosphorus: 1s2, 2s2, 2p6, 3s2, and 3p3. Right. Lithium I actually already did for you, so we're going to ignore that one for now. So let's look at chlorine. Chlorine is right here. Its atomic number is 17, so I know it has 17 electrons. And, well, since it has 17 electrons, it's going to fill mostly like this one, so I'm going to cheat a little bit, and I'm going to get a lot of these from the one up above. All right, and so I'm going to stop here because my next sublevel wasn't actually filled. So I know that 3p is where I'm going to work and see if I need to fill it or what I need to do. So again, I have 17 electrons. Right now I've used 2, 4, 10, 12, which means I need to find a home for 5 more electrons, because 17 minus 5, or yeah, 17 minus 12 is 5. And so p orbitals fill with 6. And so all 5 electrons will fit in that p orbital. And so it stops at 3p5. Right? Let's look at, sure, we'll do manganese. So manganese is right here. Manganese has 25 electrons. So I'm going to skip that one. All right, so if we have 25 electrons, I am going to have to find a home for all of those. And so again, I'm going to start at 1s, and I'm going to put in 2 electrons, then it's full. Then I'm going to go to 2s, and I'm going to fill it. And then after 2s, I go up to 2p, and I'll fill it with 6. And then I'm going to go to 3s and fill it with 2. After 3s, I go up to 3p, and let's do 6, and then let's count and see where we're at. I'm at 2, 4, 10, 12, 18, so I have 17 more to go. I'm going to mark right here that that's 18 for me. All right, and then I'm going to fill after 3p, 4s, and I'll put in 2. All right, after 4s, I go and I am filling 3d, and so 3. Okay, after I filled my s orbital, I was now up to 20. And so I need to find a home for 5 more. Well, d orbitals can hold 10 electrons. And so all 5 of these electrons can fit in there, and it won't be full or anything. And so I'm going to stop with 3d5. Right? We'll go a little bit further and we'll do gallium. So gallium is right here. It's number 31. And so there's 31 electrons. So again, I'm going to work this out. It's going to fill 1s2, 2s2, 2p6, 3s2, 3p6. Oh, excuse me, sorry. And then 4s2. All right, so at 4s2, that one's filled. And then again, I'm going up to 3d. Okay. D orbitals again can hold 10 electrons. So let's see, I'm at 20 when I get to here. And so I could put 10 electrons there because then that gets me up to 30. So I need to find a spot for one more electron. So after 3D, I'm filling 4p, and I only have one electron to put in there. And so 4p1. Okay. So we could do one that's just a little bit tougher here. So which one should I pick? We will try tungsten. So let's try this W down here. Its number is 74. So again, tungsten is 74. It's right here. So 74 electrons. And so this one is going to have a lot more energy levels. So again, I'm going to start with 1s. 1s fills with 2. Then I'm going on to 2s. It fills with 2. Then 2p, it fills with 6. 3s, it fills with 2. I'll mark it over here. 3p with 6. 4s with 2. 3d fills with 10. 4p, 6. And then 5s, 2. Maybe we should check where we're at. So I'm at 2, 4, 10, 12, 18, 20, 30, 36, 38. So right there, I'm at 38. And so I have a ways to go because I got to get to 74. And so after 5s, I come up here and I'm going to fill 4d. So 4d is going to fill with 10. 5p with 6. 6s with 2. And then after 6s, I go up and I'm going to start filling 4f. And so I'm going to come down here and keep working. So 4f, remember f orbitals, since there's 7 of them, it can hold 14 electrons. And so let's go ahead and put 14 electrons in there. And so right here, I was at 38. And so now I'm at 48. And then I'm at 54, 56, and then 70. And so I have 4 more electrons to go. And so after 4f, I fill 5d. And since I only had 4 electrons, I'm going to just put the 4 in there. And so that one's not completely full yet. All right, there is another way to do this, which is shorthand electron configuration notation. And I'm just going to do that in a separate little video. It won't take too long, and you'll probably like it a little bit more because you don't have to write out quite so much. All right, so I will see you here in just a bit. And again, the awkward little pause here before I get my camera shut off. I'm so sorry. This bar doesn't always like to come up. I'm gonna try to get out of here and then maybe it'll come up faster. Maybe it won't.